Okay, I think the room is cold. My name is Michael. Michael Mekuluyi. If you are a technical guy, like you write code, or you want to write code, can you raise up one hand? If you've used, I think the room is cold, so let's do an exercise. The room is cold. Everybody look at me. If I say API, you clap once. If I say API conference, clap twice. Somebody's already clapping. API. API. API conference. Okay, let's make it a little competitive. So we are going to split the room into three. So we have group A, group B, and group C. So if I say API A, group A, you clap once. If I say API C, group C, you clap once. We're going to exclude group B. If I say API conference A, group A, you clap twice. If I say API conference C, group C, you clap twice. API conference A. API A. API A. API conference C. API conference. Everybody's supposed to clap. API conference. Everybody is supposed to clap. API conference. Awesome. So today we are going to talk on monitoring your APIs. Okay, awesome. Thank you so much. We are going to talk on monitoring your APIs, and we are going to do actual stuff. My name is Michael. I am a Google developer expert for cloud and AI. And then I also volunteer for AWS as a community builder. And then I'm a site reliability engineer and also a DevOps engineer. And I also work with Kubernetes a lot. Oh, thank you. So today we are going to talk about how to monitor your APIs like a superstar. You know, I got this topic because I knew that Superman was going to come in around the time, like the event date, because I knew the date for Superman was like July 11th, and API conference was like July 18th, July 19th. So I said, you know what, monitor your APIs like a superstar, like a superhero. And today we are going to be using the Prometheus stack. The Prometheus stack is a stack of tools that are already deployed, governed by CNCF. CNCF is the Cloud Native Computing Foundation. It's a foundation that hosts the procedures and the standards for building on the cloud. So we're going to go through the microservice methodology, splitting services, the cloud native ideology. Cloud native ideology is not just building on a particular piece of cloud, but interoperable cloud. So you being able to build on AWS, on GCP, and then on Azure. So let's get started. Is this guy? Just give me a second. Let's not go to code labs yet. Yes. So let me try to go down. Cool. Yeah, this is me, Michael, smiling. And then why should you monitor your APIs? Detecting failures early. Monitoring allows you to catch errors early, like 500 errors. You want to track performance. You want to track performance. I'm going to ask a question, and I'm going to have a gift. So in this talk, I'm going to be asking different questions. And the fun part of the talk is, even if you answer the question, I will ask you to provide more context so that I make sure that you're not Googling. So we're going to be tracking performance, monitor API response time. We're going to monitor throughput error rates. You want to track the performance of your API. You're not just writing APIs just for writing API's sake. You want to say, how good are these APIs performing? How well are they performing? How much do they scale? Then capacity planning, metrics on CPU, on memory and request. Debugging and troubleshooting. You want to debug your APIs. You want to troubleshoot your APIs. So my first question, if you know it, I'm going to ask you a further question, because there's going to be a price. Let's put a price. Let's say 5,000. What are the golden signals of API measuring? If you know it, there are 4 golden signals of measuring APIs. If you know the 4 golden signals, I'm going to ask you a further question on the 4 golden signals. So let's have a countdown. 10, 9, 8, 7, 6, 5. I'm hearing somebody. Be confident. Come out. 4, 3, 2, 1. So there are 4 golden signals, right? And those 4 golden signals were put in by Google to measure APIs. You can go find it. Okay, who can say it? No prize attached. The 4 golden signals. Okay, let's hear it from you. Latency, traffic, errors, saturation. So latency, traffic, error, saturation are the 4 things that we use to measure APIs. So what is the Prometheus stack? The Prometheus stack is a group of open source software that we use to measure API. So today, we are going to be installing the Prometheus stack. Actually, I have a base installment of the Prometheus stack. We are going to be on a Kubernetes cluster today. We are going to expose some services, right? We are going to expose some services to the internet. Kubernetes, by default, is built to be a private cluster and a private segmented environment. We're going to be exposing a couple of services. We are going to be interacting with sort of like a gateway. And then we are going to be measuring API. Then I'm going to show you something that we use internally to measure traffic. I'm going to show you how we measure APIs in production with about 1 million users. So, node exporter collects machine level metrics, then keeps state metrics. So the idea is you cannot improve what you cannot measure, right? So for you to improve, you have to measure. And the idea of monitoring your APIs is just technically to measure. So instrumenting your APIs. It's not, how do I put it now? It's not the standard when you are doing SDLC. SDLC, the software development lifecycle, build, test, deploy, iterate, correct, debug, build, test, and STLC, software testing lifecycle. But what we are trying to do is we are trying to build monitoring as a culture. Monitoring as a culture says that when we are building APIs, we are testing the APIs. So we are building APIs, we are deploying APIs, but how do we improve the quality of our queries? How do we improve the security of our APIs? So you are deploying API A. With the deployment of API A, you should also deploy the metrics library to monitor the metrics on API A. So how do you instrument your API? Number one, use the metrics library. You monitor key metrics. You expose a /metrics endpoint. You label your metrics well, because nomenclature is a big deal in software engineering. And also in site reliability, monitoring your APIs, nomenclature is also a big deal. And then you consider custom metrics. And I'm going to show you an example of a custom metric that is running on Cloud Run today. So most programming languages have a metrics library, how to expose the metrics on your API, how to expose /metrics. You have in Go. I've used the one in Java. I've used the one in Python. I've used the one in JavaScript. I've had some stuff to do with the one in Go. So if you have sort of like an API rating in a language, you definitely have a metrics library. So monitor key metrics. This is where all the talk. The golden signals of monitoring, she already mentioned the latency, traffic, saturation, errors, the request rate, the error rate, the latency, and the saturation. So the knowledge of this is what takes you from being an average developer or just a developer that writes APIs to, let's say, a world-class engineer. So a world-class engineer is not just building APIs. Oh, does it work? It works. A world-class engineer is looking at how fast do my APIs run? How well do they run? What is my error rate? So in site reliability engineering, there's what we call SLIs, there's what we call SLO, and there's what we also call SLAs. What are the indicators to improve my APIs? What are the objectives that I want to achieve? Do I want a 99% availability? Do I want to drop error rates to below 0.1%? What reliability metrics am I looking out for? What alerts am I setting up? So the key thing is taking your code or taking the way you write software from just a base, I need to deploy stuff, I need to just write code. The product manager is saying it's working, the front-end engineer is saying it's working, or the back-end engineer is having some issues. We need to step above that to say, okay, we have our API spec, we have our data models, we know what kind of code to write, we have our authentication mechanisms, we've deployed software that works. Now we need to test software, we need to improve software. And this is actually what separates you from the crowd as a extremely good software engineer. A knowledge of monitoring, just a base knowledge. We need to monitor request rates, error rate, latency, saturation. Exposing a metrics endpoint. This is a protected endpoint that exposes, we're going to expose the metrics endpoint today in Kubernetes, because I have a Kubernetes cluster set up and I have some base installments in the Kubernetes cluster. And I'm going to show you how raw metrics look like when you hit a raw metric endpoint. So, and labeling metrics well, then considering custom metrics. Now, alerting. Alerting is an entire talk on itself, because we talk about avoiding alert fatigue, we talk about designing the right type of alerts, we talk about naming alerts, we talk about ensuring that alerts do not go overboard. There are a lot of things that we can factor into our alerting that just improves the quality of our alerts. Alert fatigue is a condition where you get so much alerts that you no longer focus on like the quality of your alerts. And we are using Prometheus. Prometheus is our tool to write alerts. So we are going to be using 3 tools. Number 1, our visualization tool is Grafana. Our time series tool, that's the tool we use to store, write, and promote time series, is Prometheus. And then Alert Manager is the core alerting tool, where we define how we should alert, what channels we should alert, and what pages we should alert. And we are going to see that today. And these are advanced tips in API monitoring. They are pretty advanced. We have distributed tracing. So distributed end-to-end tracing, putting debug points in your code to check the individual spans of the code and check how information flows from one point to the other. This is actually called debugging. We have black box monitoring, monitoring internal logic, monitoring SSL certificates, monitoring internal HTTP versus HTTPS versus TLS calls. We have API-specific metrics. We have SLA reporting, automated responses, and then making sure our stack is up to date. Finally, it's time for the demo and the interesting part. So, I set up a GitHub gist, a very, very short gist that is going to take us through installing our Kube Prometheus stack. I think I have an issue. I probably have to shift this a little here. If you could help me. So just a little this way, if it's adjustable. Thank you so much. And let's go. So I'm going to take all this off. We have 3 terminals. Probably need to cover the screen because there's some personal information there. So we have 3 terminals, 4 terminals open. Let's go. So we have a Kubernetes cluster that is set up in my terminal. A Kubernetes cluster is simply an isolated cloud environment, right? And I have deployed something base for you. So this is the code. I'm going to show you right now the GitHub gist, how to get to this GitHub gist. We're going to create a namespace. We're going to deploy and install the Prometheus stack. We're going to check all the resources in our Kubernetes cluster. And then we are going to expose our services. This is what somebody's raising his hand. Can we? Okay, you want me to zoom in? The guys from the back cannot see it. I'm trying to zoom in. Maybe command plus and command minus. I think we've lost some connectivity. Okay, cool. Can you see it now? Okay, let's just, I think I'm zooming in. Is it zooming in? Is it perfect now? Yeah. Let's just exit this. And we are going to do some actual deploying today. We are going to create a cluster. We are going to add the Elm repo for Kubernetes. We are going to install the Prometheus stack. And we are going to see all the resources. So I've already created a namespace called test, which is a segmented environment. Just, if you don't understand Kubernetes, just follow along. So the first thing I'm going to do is, I'm going to show you everything I have installed in my test namespace, right? I'm going to first of all clear this, and then let's see everything we have installed. This is going to take some time to run based on our internet speed, yes. So I deployed a Helm chart for Prometheus, right? And even myself, I cannot see it, but you can see that you can see the pods. The pods are deployed. Let's see if we can expand this. Let's see if we can make this bigger. And then command plus. Yeah. So what did I deploy? We are going to try to, if we could just use, if we could use only one terminal, we're fine. I could also try to divide the terminals. But what we deployed is an alert manager pod. We deployed Grafana. We deployed Prometheus node exporter. Then we deployed core Prometheus. So we are going to be pod forwarding to the individual pods to see how they look like. So I have everything here. So let's pod forward to Grafana. Let's see how Grafana looks like right now. And then we click on the pod forward. It's pod forwarding to localhost 3000. So let's go to localhost 3000. And let's see. So we have Grafana on localhost 3000. Grafana is what we are going to, so I have a group of services that are deployed to a Kubernetes cluster. And then this is what I'm basically going to be using to visualize my metrics. So I have Grafana, and I'm pod forwarding on localhost 3000. So I can show you the dashboards that we already have in Grafana. We are monitoring our core DNS. You probably might not see a lot of data. Core DNS is like core Kubernetes stuff, so you probably don't need to know that. And then alert manager, probably not a lot of data. So, but you can see examples of the way the dashboards are going to be flowing. So this is just monitoring core Kubernetes components, nothing specific to any API. We are just viewing how Grafana would look. So our core monitoring tool, Prometheus. So I'm probably going to maintain this terminal because I want to keep Grafana open. So I will come on this terminal and I will expose Prometheus. I don't need Prometheus to be open completely. So I will show you how Prometheus look like. Don't worry, in your career, you still get to see Prometheus. Don't mind me, I'm joking. That was a dark one. So, but as you advance, you get to hear of Prometheus. So, localhost 9090. This is how a lot of DevOps engineers, we just deploy stuff because we just like deploying stuff. So, localhost 390. Let's go to localhost 9090. So, we are keeping Grafana open and we are streaming on localhost 3000. We are going to Prometheus and we are streaming on localhost 9090. And it just goes to the default /query. So this is how Prometheus looks like. This is just like base Prometheus. If I want to run a quick Prometheus query, I can do up. I can just do up, and it will show you the values of the query. Again, I need to, so it will just show you, these are raw metrics, right? Just raw metrics. Is this JSON? Yes, just raw metrics in JSON format, like just raw container metrics. And this is how we actually get them from the logs. They look very ugly, but by the time we visualize them, you'll be like, oh wow, this is what we have. So now we are going to deploy an application on Fast API. We are going to deploy the application, and we are going to hit a raw/metrics endpoint. So if you instrument your API properly and you expose a /metrics endpoint, I'm going to show you how it's going to look right now. So some guy that is my friend already deployed everything that we need to do in config maps. So I'm just going to come here, go to app.sh. I've cloned this already. Let's check in this guy. Okay, this guy is already where we are supposed to be. So don't forget, we are streaming Grafana, we are streaming Prometheus, and now we are about to stream another application. So, plus, and plus, and we have all our YAML files here. So we are going to apply all these YAML files, and we are going to test our application. That means we are going to stream our application and apply dot. So kubectl, apply f, and then we are going to deploy the API. So we've deployed a fresh API, very quick. Like, I do not have to log into a code base or type in npm test or type in npm dev. I just have the image of the API and I deploy it. So this API is deployed. I'm going to stream the /metrics of this API. Or I'm going to even stream this API. So let's port forward this API. Let's port forward this API. Let's stream it locally. And let's go to localhost 8000. So we are port forwarding to localhost 8000. And let's go to localhost 8000. Let's see what's going to tell us. Hello world, the basic API, right? A very basic API. Sadly, we are not monitoring phone calls. And let's see if we can do /metrics on this basic API. Come on, and this is how it is. So this is how your metrics come out by default. They come out in, is this JSON? Yes, this is JSON with a structure. They come out in JSON format, and you can just see them, the type help, the type, and the counter. So counter metrics, just raw metrics. And we just deployed all this stuff in like 5-10 minutes, and we expose this /metrics, and then we are fine. So Grafana should have picked this up. I'll go to Grafana, and I'll go to dashboards, and I'll try to refresh. Let's see if Grafana has picked up Fast API. You can see the Fast API Python dashboard is already here. Because it's a fresh API, I do not expect a lot of metrics. Now I'm going to show you a production application that actually has a lot of metrics being monitored. So Fast API, you already deployed it. I can only see memory usage because, of course, we've not hit the API. We've only hit the API once. So, of course, there's no data. So this is just a baked example. And then you can get the gist here. You can go to, so to practice at home, you can go to bit.ly/2520 API. It's actually 2025 API conference. But I deployed this like 5 minutes before I got here. And I just put 2520, something that can stand out. Now I am going to show you how standard APIs look. This is Grafana. So I am going to log into something that monitors millions of API requests. Okay. This is an example of measuring API requests. This is just a short example. You could see availability, how we measure availability, minimum availability, maximum availability. I don't know if you can see it. Let me just try to. You can see minimum availability, maximum availability. You can see that we are measuring availability, we are measuring reliability, and we are also measuring latency. And then this is something that monitors over 10 million APIs worldwide that I deployed. And then you can see the drop in availability. I think it's off now. There's somebody from technical. So technically is just measuring, seeing your drop in availability, the drop in reliability, plotting your API metrics, making sure that they're properly displayed, and just using the Prometheus stack. So that's pretty much it anyway. We'll just see if we can still go live so that I can just round up. And is it coming up? Okay, so that's pretty much it for the demo. We've streamed Grafana live, we've streamed Prometheus, we've streamed our new application, and I've showed you how metrics look like on a /metrics. I know that it might look very strange because this is very new, but like I said, this is the kind of core knowledge that separates just building a get, post, delete endpoint to monitoring your APIs and making sure they work. So in conclusion, continue to monitor your APIs, continue to make sure that you pick the measurements on your APIs and you alert on the necessary things. And yeah, additional resources, SCR, you can get from Prometheus, from Grafana, and from the Prometheus stack. And then yeah, feel free to connect with me on LinkedIn, on X. You cannot connect with me on grafana.com. That was a mistake. And on GitHub. And if there are any questions, because this is a core workshop, if there are any questions, we can take 2 questions. Mr. Timer. We can take like 2 questions, yeah? So if there are any questions, this is a core workshop. So it's a core programming workshop, core knowledge workshop. If you have a question, just raise up your hand. We are going to take like 2 questions, and then that will be it. If you don't ask a question, I'm going to ask my own. Does anybody have a question? Okay, cool. Just say your name, what you do, and then your question.
I'm Anointed, and I'm a backend engineer. So I integrated, like, I worked on an open source project that used Prometheus once, yes, and I did not really get how they were seeing the metrics, but I just like integrated it because I use Golang. I can write Golang. So I just like used the SDK to work on it, yeah, to export Prometheus, but I did not like really get how it got exposed to like the dashboard.
So Prometheus has a time series database running behind it, and there's a push-pull mechanism. So the core Prometheus algorithm is very complex. I want to see if I can get it up. The core Prometheus push-pull model is very, very complex. Prometheus push-pull model. So let me see if I can get it up exactly. This is it. Come up, come up, come up, come up, come up, come up. So this is the core Prometheus model. As you can see from the core Prometheus model, there's a time series database here. There's an HTTP server here. Prometheus, what Prometheus does is it just queries your instrumentation, whether it's a web UI, Promless, and CFAN, and just pulls it. And then it sends the alerts to Alert Manager, and Alert Manager forwards to anywhere. So this is the core Prometheus push-pull model. It has a data retriever, a TSDB, a time series database, an HTTP server. It just queries data from whatever instrumentation you have, because I can do my own instrumentation. I do my own instrumentation at work. At work, I write my own custom metrics because I work in site reliability. And then I send it to Prometheus, say, hey, this is what I want you to pick, this is what I want you to pick. And then Prometheus passes it through this, and then sends the metrics down. So yeah, that is how we do what we do. Any other question before we wrap it up? Okay, so no other questions. Thank you very much. Feel free to connect with me on social media, and I hope you enjoyed the talk. Yeah. The organizer said this time, which is weird. This is the first time I'm hearing this time. So, any more question? We can take one more question. Not just about Prometheus. Like, we can open the floor up. We can take a question about career, take a question about backend, take a question about, don't ask me which programming language is better. Take a question about what to do next, what to focus on, what certification exam should you write in 2025. Don't ask me if AI is going to take your job. Well, yeah. Okay, let's not give anointing. Let's give our brother in blue jeans.
Thank you very much. Okay, so my name is Toby and I'm a software engineer. So the question I have is basically for information's sake. This is the second time today that I'm hearing about Kubernetes, right? And there's a conversation I've had around this. So what is a practical step for you to switch from your current deployment processes to now start using Kubernetes? So a lot of people say use Kubernetes, but there are a lot of nuances around these things. So I'd like for you to talk about that.
So that's a very, very good question. Where I work currently, we run 40 Kubernetes clusters, and we run 1,600 containers. Google runs 2 billion containers of Kubernetes, and over 5,000 clusters for Google's services. Netflix is on a massive scale. Chick-fil-A in the US runs 2,000 Kubernetes clusters to manage their ordering services. Everybody is using Kubernetes. And that was the point I was trying to make. That there's a difference between when you are just an okay engineer, like you can write APIs, you deploy, you go home happy, nobody's disturbing you. And when you look at your APIs, as the other speaker said, you look at your APIs as a product. You say, okay, I'm tired of writing APIs just for API's sake. I want to level up how to deploy APIs properly. So there's a methodology we call GitOps. GitOps is the process of deploying APIs with Git as a source of information. There's what we call the Flux methodology. The Flux methodology is a way of deploying APIs with an approach to DevOps. DevOps itself is a principle. DevOps is a culture. DevOps is not a role. DevOps is a practice between developers and operations guys. So, and we see it every day where you go to an interview and they drop like a complex system design question for you. And then you just think that, oh, maybe it's just write an API. The solution to every problem is not just to write an API. Like, there are scaling issues that you face. And when you go past 1 million users, you start facing scaling issues with database response times. You start having to scale out your database. You start having to manage consistency. You start having to make sure that you are strongly consistent and your data, the CAP principle, like consistency and persistency is maintained. Software engineering goes beyond just CRUD. Software engineering has gone beyond CRUD like 20 years ago. It's just, now a lot of people are still coming up. So, everybody's introduced to CRUD first. But software engineering has gone into deploying APIs as templates, deploying APIs. Kubernetes itself is just an operating system. Kubernetes is an operating system that is installed in an isolated environment. We deployed in Kubernetes. We could not access the services outside. We exposed the services. So if you properly learn Kubernetes, I was telling my friend, there are 5 Kubernetes exams. I've written 3. I'm writing the 4th one in 2 months. If you properly learn Kubernetes, like properly learn to deploy with container orchestration, because that's what we call it container orchestration, it puts something on your shoulder when you're going into an interview process. It just helps you get jobs faster, because now you're doing things at Google scale level. Now you're doing things at Amazon level. You're doing things at world class level. It's not just a Docker file or local host. So yeah, learning Kubernetes is going to be tough. I've been learning for 2 years and I'm still learning, but it just puts you above the market just by a bit. And then yeah, the guy like, I think he raised up his hand first. Yeah. So, sorry, you have to. Okay. That means we don't have to ask you. Okay. So, the guy in black, can we pass the mic to him? Your name, what you do, and your question.
Okay. My name is Franklin. I'm a back-end engineer. I do a little bit of DevOps, but about the question he asked about how to move forward, I was going to ask. We are talking about the exams, so I was going to ask, what's your advice? What path do you think is best to go with? Yeah, just add.
Okay. No. Basically, I just wanted to say, you mentioned learning Kubernetes and all. I don't know the size of application he was talking about, and we had a discussion, and they were saying when you have less than 1 million users, why using Kubernetes? Just go serverless, right? So it's supposed to be what is supposed to happen, right? So that's just basically what I wanted to say. And I'm a backend developer, and I want to tell you that Java is the way. So all of you can learn Java, right?
I knew I was going to meet them here, the Java people. It's just like saying, watch Silverbird. Silverbird is the way. When there's Super Sports, there's Netflix. But your first question about the exams, there's a website we call Code Cloud, KODEKLOUD. Because of how in demand Kubernetes is, each exam costs around $425, so it's a little pricey. But when you are certified, But when you're certified as a Kubernetes engineer, there's also a price that you can command, right? So you can go to CodeCloud, KodeKloud.com, and then it's going to take you on just how to become, there's a learning path. On your second question is subjective. 1 million users, it depends on the application you're building. A complex application might need microservices from the scratch. A simple application with a lot of users might not need microservices. If you are using a microservice architecture, it's just advisable to use Kubernetes because Kubernetes just makes it easier for microservices to communicate. So if you have 1 million users, but your application is very simple, is a to-do app, there's no need. If you have 10 million users, your application is a monolith, right? There's no need for you to, it depends. But if you have 10 users and you have a microservice application, heavily microservice application, use Kubernetes. So it's very dependent on also your budget. If you don't have a lot of money, don't use Kubernetes. But if you have the budget, use Kubernetes. Okay.